Take a moment to look at your hand. Look at the lines on your palm. Now look up. If you are inside, look at the ceiling. If you are outside, look at the sky. We spend our entire lives operating on a scale that makes sense to us. A meter, a kilometer, a mile, an hour's drive, a flight across the ocean. To us, the Earth feels enormous. If you were to walk around the equator without stopping, it would take you a year. It feels infinite. But we are about to leave this scale behind. We are going to strip away the comfort of the human experience and try to wrap our minds around a reality so large that the human brain is not actually wired to comprehend it. We are going to ask the question, how big is the universe? To do this, we need a new ruler. Meters and miles are useless where we are going. We need the fastest thing we know. We need light. Light travels at roughly 300,000 kilometers per second. In the time it takes you to snap your fingers, a photon of light could circle the Earth 7.5 times. That is our measuring stick. 1 second of light is a distance that is almost incomprehensible to a driver on a highway. So, let's start the clock. Let's leave the Earth. We move instantly to our nearest neighbor, the Moon. It takes light about 1.3 seconds to get there. It's close. In cosmic terms, the Moon is in our lap. It is the furthest any human being has ever traveled, and yet, on the scale of the universe, we haven't even stepped off our front porch. Now let's look at the Sun. It is the dominant gravitational force in our lives. It is huge. You could fit 1 million Earths inside of it. But how far away is it? If you were driving a car at highway speeds, it would take you over 100 years to drive to the Sun. But for light, it takes 8 minutes and 20 seconds. When you look at the sunset, you aren't seeing the Sun as it is now. You are seeing a ghost from 8 minutes ago. If the Sun were to suddenly vanish, we wouldn't know about it for 8 whole minutes. We would still see it shining, and we would still feel its gravity, blissfully unaware that the center of our solar system was gone. Now we move out. Past Mars, the red, dusty world that we dream of colonizing. Past the asteroid belt, the rubble left over from the formation of our system. We arrive at Jupiter. It is massive, a planet of swirling storms and crushing pressure. Light takes about 43 minutes to reach it from the Sun. We keep going. We pass Saturn with its majestic rings. We pass Uranus and Neptune, the ice giants. When we reach Pluto, the edge of the classical solar system, we are now about 5.5 hours of light travel away from the Sun. Think about that. That snap of your fingers that circled the Earth 7 times, it has now been traveling for 5.5 hours just across our own backyard. To give you a sense of the physical scale, the fastest spaceship humanity ever launched, the Voyager probe, has been traveling for over 40 years just to get this far. Light does it in hours, but we are still just getting started. We need to leave home. We are heading for the next star. This is where the human brain begins to fail. We often see models of the galaxy where stars look like dots of glitter, all clustered together. But that is a lie of perspective. Space is mostly space. It is emptiness. If the Sun were the size of a grapefruit in New York City, the next nearest star, Proxima Centauri, would be another grapefruit in San Francisco. Between them, nothing. Just dust and vacuum. To reach that next star, light doesn't take hours. It takes 4 years. 4 years of silence, 4 years of emptiness traveling at the absolute speed limit of the universe. And that is just the nearest star. If you could travel as fast as a jet plane, it would take you 5 million years to reach it. If we pull back further, we see that our Sun and Proxima Centauri are just 2 faint specks in a vast swirling city of stars called the Milky Way galaxy. The Milky Way is a spiral, beautiful and terrible in its scale. It contains anywhere from 100 billion to 400 billion stars. Every star you have ever seen with your naked eye in the night sky is just a tiny local bubble within this galaxy. Most of the stars in our own galaxy are too far away for us to see without a telescope. How big is it? To cross the Milky Way from one edge to the other takes light 100,000 years. Imagine the history of humanity. Go back to the very first humans emerging in Africa. If someone turned on a flashlight at one end of the galaxy back then, that beam of light would still only be halfway across the Milky Way today. That is the scale of just our home city. And yet, in the grand scheme of things, the Milky Way is nothing. It is a grain of sand. We are zooming out again. The Milky Way shrinks. It becomes a flat disk, then a speck of light. We are entering the realm of the galaxies. We are not alone here. We have a neighbor, the Andromeda Galaxy. It is larger than the Milky Way, containing perhaps 1 trillion stars. It is 2.5 million light-years away. Let that number sink in. The light we see from Andromeda tonight left that galaxy 2.5 million years ago. That light began its journey before modern humans existed. It traveled through the void while ice ages came and went on Earth, while civilizations rose and fell, and it is only just now hitting your retina. When you look at Andromeda through a telescope, you are looking into the deep past. Together, the Milky Way, Andromeda, and about 50 smaller dwarf galaxies form a cluster called the Local Group. This is our cosmic neighborhood. It is a region of space roughly 10 million light-years across. If you were a giant looking down at the universe, this would be our village. But we are not staying in the village, we are going to the city. As we pull back further, the Local Group becomes a single dot. We begin to see thousands of other dots. These are other clusters of galaxies. We are part of something called the Virgo supercluster. This is a massive collection of galaxy groups. It contains thousands of galaxies, each one a separate island universe of billions of stars. But even the Virgo supercluster is just a tiny lobe of something even bigger. Laniakea. Laniakea is a Hawaiian word meaning immeasurable heaven. It is a supercluster of superclusters. It contains 100,000 galaxies. It stretches 520 million light-years across. At this scale, the universe stops looking like space. It starts to look like biology. It looks like a neural network. It looks like the neurons in a brain. Galaxies are strung out along invisible filaments of dark matter, like pearls on a string. Between these filaments are voids, regions of space hundreds of millions of light-years across where there is almost nothing, just deep, terrifying darkness. We are now dealing with distances that defy logic. We are talking about billions of light-years. We have now reached the edge of what we can see. This is the observable universe. This is a very specific term. It doesn't mean the whole universe. It just means the part of the universe where light has had enough time to reach us since the beginning of time. The universe is about 13.8 billion years old. You might think that means the observable universe is 13.8 billion light-years in distance, but it's not. It's actually much bigger. Why? Because the universe is expanding. Imagine drawing two dots on a deflated balloon. Now blow up the balloon. The dots move away from each other, not because they are moving, but because the plastic between them is stretching. Space itself is stretching. So the light that left a distant galaxy billions of years ago has been traveling towards us, but the space it traveled through has been expanding the whole time. The place where that galaxy was is now much, much further away. Because of this expansion, the edge of the observable universe is about 46 billion light-years away in every direction. That creates a sphere around us, a bubble of reality with a diameter of 93 billion light-years. Inside this sphere, there are estimated to be 2 trillion galaxies. 2 trillion. Remember, each of those galaxies contains hundreds of billions of stars, and around those stars, planets. And on those planets, who knows? But what happens when we get to the edge of that bubble? What is at the end of the observable universe? Is there a wall? A sign that says the end? No. If you were to teleport to the edge of our observable universe, you wouldn't be looking into nothingness. You would simply be in a new center. You would have your own observable universe with different galaxies that we, back on Earth, can never see. This leads us to the most difficult question of all. Is the universe infinite? There are two possibilities, and both of them are equally haunting. Possibility 1. The universe is curved and closed, like the surface of the Earth. If you walk in a straight line on Earth long enough, you don't fall off the edge. You eventually come back to where you started. It could be that the universe is a 4-dimensional sphere. If you flew a spaceship in a straight line for trillions of years, you might eventually end up back at Earth. Possibility 2. The universe is flat and infinite. It just goes on forever. Most modern data suggests the universe is flat. This implies that beyond our bubble of 93 billion light-years, there is just more. More galaxies, more stars, more voids, forever. If the universe is truly infinite, then the math gets very strange. In an infinite universe, there is a finite number of ways you can arrange atoms. Eventually, the arrangements have to repeat. This means that if you go far enough, an unfathomable distance away, you will find another pocket of space that looks exactly like this one. You will find another Milky Way, another Earth, another you. In an infinite universe, anything that can happen will happen. And it will happen an infinite number of times. But there is a trap here, a cosmic tragedy. Remember the expansion of the universe? The balloon inflating? We discovered recently that this expansion isn't slowing down. It's speeding up. A mysterious force called dark energy is pushing the universe apart faster and faster. This means that the galaxies on the edge of our vision are being pushed away from us faster than the speed of light. Wait, you might ask, nothing can travel faster than light? Matter cannot move through space faster than light. But space itself can expand faster than light. This means there are galaxies crossing the horizon right now that we will never see again. They are disappearing from our reality. Their light will never catch up to the widening gap of space between us. Every second, a portion of the universe disappears from our reach forever. We are living in a rare moment in cosmic history where we can see the neighbors. Billions of years from now, if there are astronomers on Earth, they might look up and see nothing. The other galaxies will have moved so far away, so fast, that their light can no longer reach us. Those future astronomers might think the Milky Way is the entire universe, isolated and alone in the dark. They won't know about the Big Bang. They won't know about the web of galaxies. The evidence will have been erased by the expansion. So let's come back to Earth, back to the room you are in, back to your hand. We started by asking, how big is the universe? The answer is, it is 93 billion light-years of observable light set against a background that might be infinite. It is a scale that makes our lives, our wars, our worries, and our entire history seem smaller than a single atom on a grain of sand. It is easy to feel small when faced with this. It is easy to feel insignificant. If we are just a speck on a speck on a speck, what is the point? But there is another way to look at it. Consider the complexity required to create you. The atoms in your body were forged in the hearts of dying stars billions of years ago. Those stars exploded, flinging their matter across the galaxy, eventually coalescing into a solar system, a planet, and finally, biological life. You are not separate from the universe. You are not looking at the universe. You are the universe. You are the universe awakening. You are the universe looking at itself. Out of all that vastness, all that fire and emptiness, all those trillions of galaxies, we are the only place we know of where the universe has started to think. The universe is incomprehensibly huge. It is terrifyingly large. But the fact that you, a tiny biological creature standing on a rock, can use your mind to measure that size, that you can comprehend the edge of time and the birth of light, that makes you big too. The universe is vast, but the mind that can contain the universe is just as boundless. Keep looking up.